So, hello everybody. Welcome to the fourth Convector Developer Office Hours. We will be starting shortly. Let's hang tight for 5 minutes and we will start. Okay, so again, welcome everybody, and this is the fourth Convector Developer Office Hours. If this is the first time that you join us, um, just a second. There you go. Okay, so yeah. So if this is the first time that you join us, the developer hours, what we try to do is to talk about topics. There's no fixed agenda. Actually, we don't really prepare materials for this. We just make questions in the community, and sometimes you tell us what you want us to talk about. And sometimes we just explore some new features or some news that we have. So as every week, again, thank you for joining us in this opportunity. Diego won't be able to join us. He's sick. He is fine, but it's better for him to rest. So I will be leading the conversation right now. So as always, you can make questions in the Discord. We have this developer office hours channel in which you can make your questions in real time, and I can go answering them on the road. But also you have YouTube, in which you can also make questions directly. And again, we appreciate when you share these videos and you share information about Convector, because great technology is nothing if people are not using it. And community is all that Convector has, and we really appreciate when you help it. So for today, as we discussed in the channel, in the Developer Office Hours channel in Discord, I wanted to talk about a real life application, a real life prototype that is expected to be taken to production. So in this opportunity, I asked for permission to InstaMed. InstaMed is a healthcare payments company in the United States that is creating and bringing an international standard for data into the blockchain. They have this great vision of building something that is open, that is accessible to everybody. So the source code is open source. I will walk you through. It has an interesting architecture as well, and it can show you how complex a project in Hyperledger Fabric into easier maintainable pieces with Convector. So this will be a great opportunity for you to see how professionals around the world are working with this technology, so that you, with your use cases and your projects, you can learn from them and you can also give feedback. So again, before we deep dive, you can ask questions at any time. This is the goal of this. My screen most of the times. If something is not clear or something like that, please let me know. So this session will be mostly focused on architecture. And in this example, I will walk you through the code, and I will also put some recommendations and some feedback that we see around when you are architecting a solution. So I will share my screen right away to get into it. Let's see. So I should be sharing my screen already. So just as a quick friendly reminder, all the information about Convector is at worldcu.tech/Convector. In there, you have all the links to communities, to the YouTube channel, to the Discord, to Convector, to Hurley, and so on. So feel free to visit the page, and if you have feedback, again, we can apply this. And I am really focusing on the feedback part of this, because this is what we need. If you want to give back to the project, this is the way that you can do. You can create blog posts, and we can replicate them, you prestige and giving you recognition in the community, or you can just share information, or you can give feedback. In either way, it really helps us. In this specific case that we are going to see in this project that this company InstaMed created, is a great example on how feedback is valuable, because while they were developing the solution, they asked us for features that made sense, that was feedback for us, and we implemented them. So Convector changed and improved and evolved for you through the feedback of this case and other cases that we may be talking about during this call. So the project that we will be getting to know is called Healthcare Payments Blockchain. It is on InstaMed's GitHub account, as you can see in here. So the URL, I will paste this in the YouTube so that you can go to it. But let me explain you how this project is stuck. What are the main ideas behind this? And then we can deep dive in the code. So this is from their official information. Again, InstaMed allowed us to talk about this use case, to share it with the community, and the code is fully open source. So the project is for the healthcare payments process. So the idea is pretty simple. If, for example, you get a heart attack in the United States and you have to get a surgery, when you are translated from your house all the way to the hospital and the surgeon performs the operation to you, after all of that, you have to pay a lot of people. You have to pay the ambulance, you have to pay the surgeon, you have to pay the hospital, and all different, a lot of different participants. So usually when you are insured, when you have an insurance policy, it's going to cover some percentage of these bills, but not all of them. So usually you end up paying a lot of participants around, like paying the ambulance with some paper-based process and paying the hospital and so on. You know, it gets really complicated. People get confused. InstaMed is a company that gets in the middle of this issue, and they help them create efficiencies for all of this. But their vision regarding blockchain is that InstaMed is one of the nodes. It's one of these companies that help connecting these payers and these providers. So they are expecting to make things better for customers, to create a better customer experience, and to streamline and help this payments process. So in here you can see all the information. As I was telling you, these guys are industry experts. They have all the knowledge that is needed to design something like this. So here's information about what are the pain points of the patients, of the payers, of the providers, and so on. And here are also the links to, for example, the demo that is working, and it is live. It is working on top of Forma, which is one of World Cebu's paid offerings. Just like we have Convector, which is open source and free, and it's open. In general, we also have these paid offerings, and in this case, this specific platform is deployed in there. It's an infrastructure orchestrator, a multi-cloud infrastructure orchestrator that you, if you want, you can check it out and then ping us to talk about it. So let's get into it. Just to talk a little bit about the architecture, I cover some basics. Even though I know a lot of you guys already are experts in blockchain infrastructure and in blockchain architecture, I know that not all of us are. So I want to cover some few topics so that when we go through the code, it's clearer for you. So the thing is the following. Since blockchain is this big topic, this big spectrum of technologies, sometimes it gets confusing on how can you create a solution or how you manage things like users and identities and servers and architecture and so on. So I will just take a few minutes, like 5 minutes, to cover these basics on architecture. So the basic component of a blockchain solution are the nodes. So the nodes are these servers that you can see when you are installing Hyperledger Fabric, for example, with Hurley. This is just software that is going to in which you are going to upload the smart contracts, and this is going to emulate transactions and so on. So usually this infrastructure has to be owned by somebody. It could be a company, and usually it's a company. So unlike public blockchains, in which everything is permissionless, and customers, for example, can even get a node if they want, in an enterprise scenario, usually the guys that are holding these nodes are companies. So these are enterprises that are keeping this in their data centers, and they protect the servers and so on. So this is the first part, the first party in a blockchain network. So usually you have multiple companies and multiple enterprises or public sector or companies like that that are holding the infrastructure. That is the first layer of a blockchain solution. So in this case, enterprise solutions need some compliance usually. So for you to comply with regulations, you need to manage cryptography. So usually when you work with something like Ethereum or something like that, it is simple to create, a new wallet or something like that, and then start making transactions. In this case, in enterprise setups, it is different. You have to comply with some regulations. So you usually use what it's called PKI, which is infrastructure for private key. So what this means is that instead of just having independent certificates, like you would in a public blockchain, for example, you can have a whole structure of certificates, which is kind of like a tree of certificates. So you can have something like I have this root certificate, and then I have a certificate that inherits from this one, and then I inherit also other certificates. So you create this structure that goes something like this, in which, for example, it works pretty much like a tree. If this certificate, for example, gets compromised, it gets stolen or something like that, you can get rid of the whole branch of certificates. So you can have much more control. You can have a much more manageable way to create certificates. And with this structure in which you are creating this, you can also delegate some tasks and delegate certificates. So usually this is what it's called in Hyperledger Fabric, the Fabric CA server. It's called Fabric CA. So it is in charge of generating certificates. With at the end can be identities in your blockchain. So this is fairly important. These certificates can be used to sign transactions and send them to the blockchain. Therefore, this could be used to identify parties in the blockchain. So usually what you do is you create a user. So Fabric CA it's basically, from a conceptual perspective, based on users, and then users can have certificates. I can have one or multiple certificates, and every single component in a Hyperledger Fabric network needs to have certificates. Everything that is shared should be signed and encrypted when needed between the parties. So, for example, let's say that we create this certificate, which comes from what is called an organizational unit. For example, I want to create an organizational unit for all the nodes in my blockchain. So I create this certificate, and in this case, I can a little bit of color to separate this from the rest. I can take this certificate and I can this node. So when this node is talking to another node, so a node from another company, it can be identifiable by this certificate. So this other company can have their own separate cryptographic structure. And they could have their own separate cryptographic structure, and they can create also a certificate, and then they can assign this certificate to this node, so that when the communication goes the other way around, this other organization can know who is this and talk to them. So this is important because this is the basis for identity in Hyperledger Fabric blockchain. The next layer of communications are what are called, sometimes these are called applications. Sometimes these are called consumers of the blockchain. These may have multiple names, but this is usually a server. What communicates directly to the blockchain nodes are servers or APIs. So these guys, usually they keep also a certificate. So for example, in here, I can give this another role. In this case, this is going to be a consuming certificate. So what happens is the following. When you talk to the blockchain, in this case, let's move this to the right, because this is actually from this organization. Somebody has to make the calls to the blockchain. And calls to the blockchain in Hyperledger Fabric have to go signed. by the party. So it is easier to understand who is making transactions, and it makes every change evident. So in this case, this certificate is going to be used, for example, by Fabric's SDK, or by Convector, which actually uses Fabric SDK. At the end, it's the same, to sign transactions. So when somebody is making a request, let's say that we have this web application that is making a request, this doesn't have to know about the blockchain. It's not really a concern of this web application. It doesn't have to know. So this web application is going to make a call to this server API. This server is going to sign this based on this identity through the SDK, and this is going to communicate to the whole blockchain. And how is this happening? This happens through what is called the network profile, that you may have seen this already, as Hurley usually create this automatically for you. So in this case, let's say that we have this network profile, which it has all the addresses of the blockchain participants. So it has things like URLs and certificates and TLS related matters for SSL. So when you have this network profile is storing here, and the SDK understands the network profile, understands the identity, and sends the transaction signed. So here's a common confusion. Usually people ask things like, how can I create a certificate for an end user? So an end user is usually right here. This guy, this end user may be like a customer, or it could be something like a patient or a doctor or something like that. They communicate with this web application. They don't necessarily need to know that there is a blockchain behind the scenes, because all they want are the benefits, not the complications of a blockchain. So you have to find a way to manage these identities separate from the blockchain. There are some patterns that have been around for a while called self-sovereign identity. These self-sovereign identities are a way for end users like these ones to create their identity and to manage it by themselves. There's a project in the Hyperledger ecosystem called Hyperledger Indy, which was graduated just recently. So it's really an interesting project that you should check out. It is not integrated with Fabric yet, but it is an option to generate identities for this part of the architecture. So why am I making so much focus on this architecture part? It's because to fully understand the code from InstaMed, you really need to get a grasp of how this works. So in this case, this could also have another APIs. This could also have IoT devices, or you could even have multiple applications with other certificates. So for example, I could create in here another certificate. In this case, I am going to create a certificate for another server identity, which is going to be dedicated for Internet of Things transactions. So I just give this an identity. I put this certificate in here, and then all the IoT devices go in here. So when a transaction is submitted to the blockchain, it's going to be signed by this certificate. And when transactions come from a web application, it's going to go sign with this. You can always, for example, do things like put both certificates into a same application, and then you can do some logic in here. For example, I could have an if statement in here to do things based on some conditions, and I can use one or another identity. But at the end, these identities are for servers, not for end users. You could use them for end users, but there are a lot of difficulties that you will be facing in that scenario. So what we will be seeing is the following. In the InstaMed example that I will show you, we have the whole blockchain. It is created locally for your computer with Hurley. We have the smart contract at the end. The smart contract is set in these nodes. We also have a server. The server is built with Convector as well, and then we have a front end. So if you are curious about the stack, at the end it is the smart contract is obviously built with Convector. The backend is built with Node.js and Convector. And then we have the web application, which is built in Vue, like this. So we will be seeing how these parts of the application in this example from InstaMed works. So if everything is clear so far, we can deep dive to the code and take the rest of the webinar into that. So if you come in here, if you go to the repo, you will see that we can see this packages folder. So as you know, we use Lerna for this management of projects. Lerna helps you manage multiple packages, so you can have scalable, maintainable pieces of code. So in this case, we have administration, which is for some administrative tasks, for example, like creating some mock data so that you can make tests, for instance. We have the financial CC folder, which is there is all the code for this project. We have the front end and we have the server that we talk about. So how can you get this project started on your side? You can go in here, you can fork this project, and you can follow these instructions. The instructions are fairly straightforward. You do npm install, you start the blockchain server, and install the chain code in the blockchain with Hurley. And then you run this mock data, and I will go through all of this in detail in a little while. This mock data is going to create some registries so that you can play around with the interface without having to create like a patient and then creating a hospital and then creating an insurance company. It's just to make things easier. It's not mandatory, obviously. And then we have the way to start the server in this case. We have the first question in the YouTube channel. It says, can we associate an external authentication like user ID with an identity inside a wallet? What are the pros and cons? Let's see, with an identity inside the wallet. Yes, you could. You could do some things in there. You can, for example, use an external identity system like an LDAP database, for example, to keep them. Or you can also associate identities with wallets through the code in the smart contract. I believe that the best way to do this is actually on the smart contract. So you can create a package for the identity, because the thing is, identities are relevant. And I mean, external identities like users or even companies are relevant in your code. It makes no sense. For example, if you have an ID, but you have no way in your smart contract to validate if the transaction that is coming from outside is actually coming from that identity. So you need to diagram this specific data in some way in the blockchain. You could also use identity systems like an LDAP. To this, you will need to manage the database from Fabric. That is a great way to manage server identities. But at the end, if you are managing end user identities, for example, it is in either way, whether you use an external identity database like LDAP or not, you will have to represent these identities in the blockchain. So there's this project in our GitHub where we have these identity patterns. In this, we associate pretty much wallets, which are the certificates, with identities in the blockchain. So you can check this out, and we can deep dive later on identity patterns. But in general, the best thing that you can do is have a way to reference users. If you don't have a way to do that, for example, if you keep all your users outside of your blockchain, for example, if you create, let's create this example. You have an Oracle database with users, right? There is no way for the blockchain to go to the Oracle database. The smart contract is never going to be able to do that, because in a blockchain, all the data that is processed has to be always the same in time. So an external resource like a database may change over time. So that is an anti-pattern. So you will need either to have an Oracle, and in this case, not an Oracle database, but an Oracle in the blockchain concept, which is a service that is putting data into the smart contract so that the rest of the logic can interact with that one. So just to close the question, there is no way for the smart contract to communicate with an external identity. You have to put the data in the smart contract. And the next question says, if I'm not wrong, Fabric CA is not recommended for production usage, right? Not that I know. Actually, Fabric CA is the recommended way. Maybe you were seeing some temporary containers, but Fabric CA is actually a best practice for production usage. What you could do is that you can manage your very own certificate authority outside of this. But no, as far as I know, it is actually a best practice. This is why Fabric CA is like a separate project inside of Fabric, and it has a lot of heads thinking on how to make this better and more secure. So let's go to the project. You can go to the code. You can download the code on your computer by cloning the repo. And in here, you can start the project. And as soon as you start your project, you run npm install, you run npm start, you run npm run mock data, which is, we can go into mock data in here, and we can see this script. If you go to the package.json, let me do some little bit of zoom in here. There you go. Like in here, we have this mock data task that we are calling. What it is doing, it's going to packages, administration, dev-env, set up mock data. So for example, if I go to that folder to see what is going on in administration, dev-env, set up mock data, it's a script that is going to create some data in the blockchain. So it is making some calls through Hurley. It's using some users. And if you go through all of these, you can see that these are just JSON values that we are submitting into transactions in this code. And this is actually pretty much the same as taking this file, this JSON file that is called firefinancial.postman collection. You can open this in Postman, and you can see all the transactions in there, and you can actually mimic the same mock data, but manually in this case. All right, so as soon as you start the project, and you can see also the architecture in here for this specific project, as you can see, we have the basic structure and so on. As soon as you start the project, you can go and you can navigate to this URL, http ://localhost colon 8080, and this is going to open this this screen. So what is this screen? How can you explore this screen? You can go in here and you can go to the front end project, and you can see that here is all the view code, all the files in there, all the files as well. What it is doing, it is, if we go to the Aperture diagram, this application, this front end is going to the server, and it is making calls to the blockchain. So the server has the identity at the end. So for example, if you're a hospital, you probably want a node. If you are a payer, or if you are an insurance company, you want to have a node. So you will have your own identity in the blockchain. So you can come in here and you can start the demo. The front end is creating random data on purpose. The idea is that you won't face issues by submitting information in here. So we can come in here and we can create a claim. It's going to the blockchain, and it is making multiple transactions. And I will show you in the code how InstaMed made this. So I already created a claim. I can take this claim and I can go to the next step in the payer position, and I can approve the claim. In this case, this is an insurer approving to pay your policy. And then the patient can see the results, and you can see that you have to pay a small amount of the whole bill, and you can pay in there. And it completes the whole round of the logic of this specific business case. So this is how you can start this front end, but you can also go in here to the repo, and you can see all the data that is being created for you in the CoachDB. So I can go into this URL, I can go directly, even though the URL is on the internet. It's because this is running on Hurley, so it's normalized. And you can see all the data in here that is created. You can see that there are some best practices. For example, IDs have this unique notation to make sure that there won't be collisions on the IDs. So this is actually a best practice that is implemented in NoSQL databases, and it is brought to the blockchain in this case as well. So as you can see, here's all the data. Here's something interesting and something that is important for you to know, is that this specific case, it is using something that is called HL7, which is an standard, an international standard for healthcare. It is using something specifically that is called FHIR, and inside of the whole standard FHIR, it uses the financial model. So this code that we have in here that we can access is actually implementing an international standard for data structure. This is really a big deal. FHIR, the version 4 that is implemented in here, is really recent, and InstaMed already implemented this in the blockchain. So if you see some weird things in here, it is because these are requirements from FHIR directly, so that companies using this information can comply with the regulations. So let's go to the code, and let's focus the rest of the minutes in this structure. So I'm going to go to this financial CC folder. This is the chain code. This is all the logic of the project is in here. So if you go to this SRC folder, here's all the logic. And you can see that we have multiple controllers in this case and multiple models as well. So this is the logic. A project, in this case, this folder, this package that is called financial, has multiple controllers. So when you are installing this, you need this chain code config file. We have talked about this previously, but just to make a quick wrap up, you have to say all the controllers that you want to be included into the chain code. Otherwise, when this is installed, it has no idea on who they are talking to, because the idea, this is the thing. In terms of data, everything is stored in a smart contract, in a chain code, in a channel, is in the same package. So for example, if I create something with the ID 1, or I create something with the ID 2, and these two models are from different types, for example, one is a participant and the other one is a patient, at the end, it's the same store. So you need somehow to create a logic behind this. So let me draw this to make this clearer, because sometimes it may get confusing. In terms of storage, it's just one store. It's one store of data. That's it. There's no much more logic behind this. But the thing is, if you create everything into a single store, and you also put all of your code logic into a single file, it's crazy. You cannot scale in this way. So with Convector, there is this concept of controllers and models, which are kind of artificial concepts that allows you to, even though you have one store of data, you can have multiple models in this case, which at the end are in the same single store. We don't change fabrics pattern, but you can have something that is called patient, and you can have something that is called participant, and you have something that is called claim. And then instead of having a single file, we break this down into files that are more manageable. So you have controller for claims, and then you have controller for patients. But at the end, this is the same as with the data. This is just one that is logically separated for you. So when you are maintaining a code base, you can work on the controller claim without changing the payments claim. Or you can work with the patients without affecting the participants, and so on. So this is fairly important, because sometimes Convector makes you think that this is like a SQL database in which you have tables, and then in which you have logic that is modularized. It is for logic, for development, and for design. But actually, when this is running, this is all the same. All these are methods in the same chain code. All of this is data in the same store. So this is fairly important. In this case, in this file, as I was showing you, we say which controllers we want to put together to work. And then when we deploy everything, these controllers, if this controller calls this one, and this one calls this one, they can see each other and they can interact and all of that. So the most important file in all of this project is this one, the one that is called financial. In this case, the innovation team in InstaMed created a translator file that took the fire standard, the fire specification, which is a big XML, if I'm not wrong, a big XML file with all of these fields, and they created something that translates that XML into Convector models. So all this file that you can see in here, it was self-generated. It was generated by this software that they created. So you can see in here that they have a lot of models. These are literally a lot of models, as you can see. It has models for extensions. It has models for backbone elements, simple quantities, which these are part of the fire specification. And you can go all the way through this code to see how they implement all the combinations of models or logic or structures that you may think of are probably implemented into this file. Because fire is really complex, and Convector is taking that complexity and creating these logic, these structures. So as you can see, this is actually a really extensive file. This is 21,000 lines of code. And it is using all these validations according to the standard specification. So it is great that you can go through this group of models in which you can see how a lot of combinations of logic can be implemented. So this is the main file, the financial models file. There's also a participant model. This is the way that identity is managed in this case. It has payers, it has providers, it has consumers, and it also have the participants at the end, which are these are extended versions. At the end, consumer participant is actually inheriting from participant, and it is implementing some extra properties. So this file manages all the identities. As you can see, they have multiple types of identities: consumers, providers, and as we were seeing before, payers as well. So in the controllers, at the end, they have this claims controller, for example. They have this participant controller, this patient controller, and this payments controller. This is logic. This is based on their logic. All of this code could be into a single controller, but that is not maintainable. That doesn't make sense. That is not the way to do reliable code. So if you go through one of these controllers, you can see that these are pretty straightforward. Some of them are much more complex than other ones. For example, the claims one, it has a way to create a claim. It has some validations, for example, in here. When you are coding, that if you are trying to assign, for example, a participant, you need to have a way to validate that the participant actually exists in the blockchain. As we were talking about identity, it doesn't make sense for me to say in the blockchain, this model is owned by this company with the ID 1, if I cannot reference this in some way. It also has some interesting things like reusable components, like these functions that are helping to make initialization of complex properties and nested properties easier to build in here. Something that is interesting and that happened through this, and that's why I was so focused on telling you about giving feedback to the core developers, is that when they were implementing this, the fire specification needed circular dependencies. And that was something that Convector didn't support before InstaMed developing this. So they told us about this, we understood the need, and we created this jup.lazy function that it is allowing these models to reference each other. So what it is doing, it's actually making sure that, for example, if there are nested models and one model inherits from another model that already contains this, that is a circular dependency. So to avoid this breaking, because we cannot change the specification, we cannot change the international standard, right? You can do this job.lazy, and then you can reference the model that you know that this is going to generate these circular dependencies. And in this way, you can still have circular dependencies and still have validations through these decorators in Convector. So this is important. This is a really interesting thing, because we have seen that other tools like Composer do not support this, but you can do in Convector. So we have this controller. I want to show you something specifically, which is a call to CoachDB. Let me see if I can find this. Yeah, there you go. So as you know, Hyperledger Fabric uses CoachDB as what is called a world state, which is a database generated from the latest data of the whole state of the blockchain, like not the transactions, not the historical transactions, but actually the latest state, the latest version of everything. And you can query directly to that database, which the reason why we have a database separate from the ledger is because sometimes you need to do things like what we know as joins in SQL databases, for example. You sometimes need to do, you need to manage indexes, or you need to make complex queries, like give me all the patients that have had an accident in the last 10 days. Those kind of complex queries will be really expensive if you do this to the ledger. So you have CoachDB. In this example that we have in here, it is actually going and calling this query function, and it is passing this, this is called a Mango query. And it is saying, okay, let's look for inside of context, inside of identifier, inside of value. So this is a property inside of a property inside of a property for this value. So this is a nested query that we are making right here. And you can use this as this simple example, or you can do much more complex things, like look for this into this array, for example. This, again, you can go through all these controllers. As you can see, it also implements unit tests. So it has this end-to-end unit test. As you have probably already seen, we really encourage people to create and to use unit testing. These all the efforts that we make for Convector is for you to have a maintainable code base, something that can be understandable by the developers, something that can evolve over time, something that is not going to bug you in the future. So this example, InstaMed already created unit testing. So you can go in here and you can see how they do these things. For example, how they create these models, how they use, for example, in this case, let me show you in here, the client factory, which is something that Convector 1.3 brings, which is a way to initialize Convector outside of the blockchain to make calls to the blockchain. In this case, it uses a mock controller adapter. It makes some insertions of data, but it also makes validations. So it says, for example, if I make this insertion, is this so you can regularly run these tests to see if something is broken, if something that you expect. So this is really a best practice, and here's a great example for you. So let's go to the backend and see how this works. So in the backend, we have some interesting things. For example, we have this folder called Convector Utils. What it is doing, it is initializing the context to connect with Fabric. So again, if we go to the architecture diagram, now we are in here. So this guy needs some initialization, like the network profile and the SDK. So the way that we initialize the data is by initializing a Fabric adapter. It is putting some data that is coming from environment variables. And once the adapter is ready, it is initializing every single controller so that you can take that logic, right? You created a logic. You created logic of patients, payments, claims, organizations, and participants that didn't exist before. these are virtual, this is logic for your code, and you can take this from the blockchain and bring it to the backend. In this case, this is a Node.js backend. It's initializing all the controllers. So it can simply, instead of a route of these, well, let me show you this, for example. In a route of this Express server in Node.js, it can come in here and it can call this get all, which is going to a service file. And this is calling, for example, this is making a CouchDB query. In this case, this is a direct query to the database, but it can also do insertions of data, like sending transactions. So, for example, let's see, where do I find one? For example, in patient, we have this create. So the logic is that you only have to you have to initialize the adapter that we defined before, and I show you, and then you just call controllers. Let's go to the patient controller and call create, and that's it. With just this, you are already communicating to the blockchain, and you're exposing the data. If we go back to this patient controller, you are exposing the data through this endpoint. So the endpoint is telling you, okay, if you post me data to patients slash, just patient slash, and you pass an object with the patient, it is going to call the blockchain and it is going to insert the data. So as you see, this has the whole flow for you. You can go through all of this and you can see what is going on behind the scenes of what you already saw in the interface. So it's the same for everything. As you can see, it is really, really simple. You see things like controllers, that payments, in this case, this is the controller for payments, and you call make, and that's it. You are calling the chain code, and the chain code is executing this logic. And all you had to do was to use this controller configuration logic. In this case, it is calling it. You can call it whatever you want. And it is initializing the controller so that you can insert data in there. So the last part is the front end. So the front end, it's a view front end. You could use Angular, you could use React, whatever you want, because at the end, this is a RESTful API. And you can see here, it has all the structure for the HTML. It also has some logic for making calls to the API. It also has configuration. It has, for example, the routes that are loading the data. But at the end, this last part is this web app, which could, for example, be a mobile application. And this mobile application could be calling the server again, just like in this example. And you can have a much more complex scenario based on the same architecture. So again, this project is open source. You can access this. As you can see, the walkthrough is really simple, but it has a lot of interesting things. What I was hoping to help you is to understand like the flow so that you can navigate the code easily, that you won't get lost in probably all the features that it has and all the complexities that this may seem at first. But actually, if you go through the README file, you shouldn't be lost, and it should be walking through you the process and making you understand what is going on behind this great project, this great prototype, that hopefully we will be seeing this in the American healthcare system for payments in the near future, with a lot of companies involved in this. And I believe that is what all of us want to see, which is much more blockchain projects that are not only developed by the big companies, but also by any kind of companies. In this case, this is an industry expert, as is InstaMed. So if you have any questions, I don't see any other questions in the chat. And let me check on Discord. Yeah, I don't see more questions in there. If this has a delay or something like that, and you want to make questions, you can put them on the YouTube, or you can put them in the developer office hours chat in Discord, and we can cover them. We can go over through them, and if this is necessary, we can go in more deep dive details into the next session, whether it is questions from this conversation or just because you want to see or you want to talk about other features. So before I go, I just want to tell you that if in any time you want to join us into this Convector Developer Office Hours, and you want to be on the video call and you want to make questions or you want to bring a use case that you are developing or your experience with Convector, you are welcome to do. These conversations are led by Diego and myself, just because we are the first volunteers to talk about this. But if you want to join and you want to be much more active into the conversation, please join us. So from my side, that is what I wanted to show you. We are almost on the hour. So again, please go to the Discord chat and talk to us, make questions, talk to the community. Please share the post. You can also create content. And again, we can replicate this. We would really appreciate, and that is a great way to pay back to the community and everybody that is giving their time for free to this project that we believe that is helping, that we have seen that is helping a lot of companies like InstaMed in this case, which is the star of the project. And in this case, the start of the show in this 4th Convector Developer Office Hours. So thank you for tuning in and hope to see you in the next session. Take care.